Okay, for day 10, we're going to be starting lesson 5.6, and 5.6 deals with equations of parallel and perpendicular lines. So in this video, we're going to start just with parallel lines. And just start by remembering what the definition of parallel lines are. They're two lines that go on, and they're never going to intersect. They're always the exact same distance apart, and they're two lines never intersecting. Now we're going to look at these two parallel lines on this graph and see what we notice. See what we notice about the way they look on a graph. So the equations for these two lines have been given. Y equals 2x plus 2, y equals 2x minus 1. And you're going to notice some things. First of all, here's the y-intercept is 2 on the top line, the black line, and it's negative 1 on the blue line. But what do you notice about their slopes? Well, if they're parallel lines, just looking from the picture, it looks like their slope is the same. And sure enough, when we look at the equation, the slopes are always the same. So that's with parallel lines. The basic fact that we're going to have to remember is that the slopes are always the same. So, using that information, I'm going to start the first problem. So, this is my first example. You're going to have to stop the video and write this question down in your notebooks. The question is, write the equation of the line that goes through the point -1, -2, and this line is also parallel to the line whose equation is -3x minus y equals 2. So, in order to do this problem, I'm going to highlight the fact that I'm finding the equation of a line parallel to this line. So they are going to have the same slope. My new line will have the same slope as the line given here. But I don't know the slope of this line because it's not in slope-intercept form. So if it started out with y equals, then it would be in slope-intercept form. If it doesn't start out this way, I'm always going to have to convert to slope-intercept. So that's what I'm going to do right now. I'm going to start by taking this equation and converting it to slope-intercept. To do that, I want to get y alone. So I'm going to start by adding 3x to both sides. When I do that, don't forget that you'll have a negative y equals 3x plus 2, which presents a problem because y is not alone if it's a negative y, which means I'm going to have to multiply everything here by -1. So now my equation is y equals -3x minus 2. So this is the equation of the line they're giving me. I need to find the equation of a new line that's going to be parallel to this line, and it's going to go through the point -1, -2. My new line will have the same slope. So the slope is -3. It's going to have that same slope, but the key to all of these problems is that you'll always find a new b. Because they're two different lines. Remember our picture of two parallel lines. They're two different lines, and they're going to have different y-intercepts. So you can always find a new y-intercept or a new b. So in order to find that new b, fortunately, they've given me a point, -1, -2. And that is my x and my y. That's points that I can use for my x and y in this equation. So I'm going to substitute in -2 equals -3 times -1 plus b. Now, I'll continue solving. -2, -3 times -1 is +3. -2 equals 3 plus b. Subtract 3. and I get that b equals negative 5. Now all I have to do is go back to my equation, substitute in the things that I know. I know what the slope is. It's the same as my original slope, which is negative 3, and I now know b is negative 5. So my answer is y equals negative 3x minus 5. That is my equation that's parallel to the one they gave me and goes through the point that they gave me. That would be the answer.